Welcome to Sealed System Troubleshooting for the wash combo that uses a heat pump to dry clothes. First thing we're going to do is check the operation of the drying mode. Turn the unit on and scroll to the dry only mode. We will start that cycle by holding the power key down for a few seconds. It's going to start gathering information about the size of the load. It will take a minute before the heating starts. Let's talk about airflow. Airflow is coming out of the tub through this large tube in the back, through the filter assembly, out of the filter assembly to the side. The first core that it's going to hit is going to be your evaporator. The cold evaporator is going to make the moisture in the air condense. Then it will go through the condenser where it's going to be warmed back up. This fan is sucking the air through the evaporator and condenser, and it's going to go through a duct that goes right down the front behind the front panel, back into the tub assembly. Then it comes back out the top of the tub assembly, coming back around through this side. This pathway must remain clean or it will restrict airflow. The more lint that is collected inside the unit, the more airflow is restricted. The filter should collect most of the lint, but some lint will accumulate on the condenser. A lot of lint will accumulate if the filter is not reinstalled properly after cleaning. The lint can be removed with a vacuum cleaner. We have a service guide that helps you troubleshoot and correct drying issues. There is a video and a PDF. Now we'll put the unit into test mode. Notice where the soil and delay start buttons are located. When a cycle starts, these are no longer lit up. So place your fingers close to the button, select dry only and press start. Press and hold the soil and delay start buttons for about 5 seconds. This will put the unit into test mode. The top number is the test mode. The bottom number is the feedback. For example, a temperature reading in Celsius. Now, turn the knob and go to test number 26. 26 is duct inlet temperature. The number at the bottom is the temperature in Celsius. If you're using a voltmeter to test what the resistance actually is, everything can be tested from these wiring harnesses without disassembling everything. On the display, the temperature should be rising. With our meter set to ohms, the resistance will go down. The voltage will change and go down as well. The next test is 27. It's the outlet duct thermistor. Same as before, as that temperature begins to rise on our display, our voltage and our resistance will be going down. The evaporator input and output are 28 and 29. On the display, the temperature should be rising, but resistance on that particular sensor will be going down. The frequency of the drive going to the compressor is 30. It should read 60 Hz, letting you know that the compressor is running. Any of the test modes mentioned can be used to determine if your seal system is running properly. If you did not encounter an error when running test mode, we will now test for continuity on the compressor, fan, and each thermistor. But first, we're going to shut everything down. The main wiring harness runs across the very back of the unit. Be mindful of chafing or cutting this you're working with the unit. We're going to test across the compressor lead. The compressor leads connect up under the front cap of the compressor. Then go to this wiring harnesses. The compressor has 3 wires that are red, black, and blue, but those wire colors may change in the future. All of your windings will test the same resistance. That is roughly 2.5 to 3 and 2.5 plus or 7%. So we're getting about 3 ohms. These 3 top are away from the lock tab are your compressor, and the lower 3 are the fan. The fan is going to read the same resistance across all the coils. So we got 13.5, and we should get about the same reading on every one of the coils across that fan. Okay, so our fan and our compressor are good. Now we'll switch to the thermistor wiring harness. Test across the thermistor to make sure that we're getting resistance. It shouldn't be open. You can remove them from their sleeve for testing. Just the heat from your hand will show if the thermistor is responding. That's all for our continuity testing. Now to test the EEV. We are using LG's 3-way jig to test the EV. This connector, when you disconnect the wiring harness that goes to the EV, it will connect directly to the EV in the unit. The main menu has 4 options. Choose option 1, 3-way. In the next menu, choose option 3. With an EV, you have a choice of it being open or closed. So we're going to press 1 so it will open it all the way. You will hear it and feel it operate. It will also report that it's all open, so the coil in it didn't have a defect. We can go back to that menu. Now we can press 2 to close it. You can hear it and feel it as it closes. That completes the EV testing. We found no issues. Further discussion with this sealed system assembly. There's a fan that's up here at the top right. This fan only has 2 wires. And this fan is not being monitored by the main board. It's going to come on at different intervals during the cycle. This fan not spinning is not a main assembly defect, so don't assume something is wrong just because it's not spinning. Something else has been talked about by some consumers. This area here and here will get hot on the top of the unit. They're going to reach around 100 degrees Fahrenheit, which will feel warm but will not burn skin. That is normal because a lot of heat is generated by the sealed system. This whole sealed system is one part. When there is something wrong with any part of the sealed system, you swap out the complete assembly. We have a separate video showing how to replace the sealed system. That's all for this sealed system troubleshooting video. Thanks for watching.